Good afternoon. I'm here to go over 22 diagnostic test, and that page 22 is going to cover 31, 32, and 33. We're going to try to squish these on one video, so let's do it. Question 31 says, a researcher wants to study the effectiveness of two different medications. 50 boys and 50 girls who are diagnosed with ADHD have volunteered for the study. So right away, I'm thinking this sounds like a design question. They're trying to figure out, was the study designed properly? So I'm going to keep reading. It says, which of the following would cause a confounding variable? So what's a confounding variable? You're trying to figure out here, ultimately, you're trying to find the difference between these two medications. The problem is, if you don't keep track of who gets what medication, then whether or not somebody gets better, or whether or not someone gets cured, or whether or not someone's blood pressure or the amount they act up in school may or may not go down if we don't keep track of who gets which medication. So when I read through this, I look for the one that makes this sense-o-meter go off and be like, wait a minute, that sounds like a bad design. It sounds like my scientific brain would sense something is wrong. So when I see this, when I see 50 of the girls, and I'm only taking 50 girls, all 50 girls are taking medication 1 and all 50 boys are taking medication 2. I immediately think that's not going to work, because we know, based on experience, that things work different for girls than guys, or men than women. A classic example of this is they did a study of men and women, and they blocked the study, but they noticed that if men stopped drinking diet soda, they lost on average 20 pounds. And women, if they stopped drinking diet soda, they lost on average 5 pounds. So the women were very mad. But the average was very different. And so if we don't block, then we can't really compare the average amount that the women lost versus the average amount the men lost. So in this essence, in the same scenario, I can't really compare after the study the average amount that the girls lost versus the average amount the guys lost. And I can't figure out the effect that the medication had on the girls versus the guys if I don't give each girl at least a chance of both medications. So I think C probably didn't get missed by a lot of people, but it's kind of a cool question. Now, I'm going to go 32, not a design question, just a basic algebra, maybe algebra 1, algebra 2 question. It says the population has only 4 numbers. That's kind of a weird number, so it's really just like a math question. What if my whole population of numbers is the number 4, 6, 8, and 10? I only have 4 numbers, so I can add those up, divide by 4, and I get the number 7, and that's what the question did. They said mu is 7, which is the average of those 4 numbers. Then it says if the sampling is done with replacement, so that's important because sampling has to be independent. So we want each, I only have 4 numbers too. So pick a random number, put it back in. Pick a random number, put it back in. It says there's sampling done with replacement and there's 16 different possible samples size of 2. So out of these 4 numbers, you're just picking 2 numbers. Like 8 and 10 and 6 and 8 and 4 and 10 and 10 and 4 and 6 and 10 and 8 and 4. That's all they did. So it sounds a lot like a simulation. Each of these samples had a sample mean. For each example, one of the samples is 8, 10, which has the mean of 9. The mean of the sampling distribution is denoted by mu sub x. So here we go again. In my formula sheet, mu sub x bar, we know is equal to mu. That number has to be the same. So the average of the sample is equal to the average of the sampling distribution. We also know sigma x bar from the last few questions here, hopefully we're getting the hang of it now, is sigma sub x bar equals sigma over the square root of n. So we know that the sigma of my sample, or that's also known as my standard deviation. So I'm going to write that down. Standard deviation has to be less. The standard deviation of my sample has to be less than the standard deviation of my population. And so I look through here and I say to myself, okay, I think question 32 has to be C, because the standard deviation, the sample distribution, is calculated by the population standard deviation divided by the square root of the sample size. So anytime I divide a number by another number, it's going to get smaller. So that definitely is what C says. Bam. Last one, 33. A local store owner wants to know if a new line of souvenir glass figurines is better. So I'm comparing, like the last one, medication 1 or 2. This time, I'm looking into the design of new versus old. So you're not going to really know the difference between new versus old unless you try to put them in the exact same setting, and the only variable is that it's the new item versus the old item. If I do anything else than the exact same setting, then it could be that setting. So an example is if I had the new product, let's say in a store, but I dropped the temperature of the store 20 degrees. Well, maybe they bought it a lot more or bought it a lot less only because it was cold. So I want to try to simulate the exact same conditions of the two items so that I have no other confounding variables and that the only variable is the one item I'm trying to measure. And so as I read through this, it looks like they're coming up with all sorts of confounding variables. So I'm saying to myself, wait a minute. The one that really, after I read through this, makes me really cringe the most is 30 on 33 is C. It says, since each is in a different location, the study has now introduced this confounding variable. So it might be where I put the product that's really controlling whether or not they buy it or not. And we know this to be true based on experiences we have in life. A person may be more prone to last-minute shopping, for example, and choose ones that are closer to the restaurant, to the register. So we see that at Walmart or Target. We notice quick items, chewing gum, Tic Tacs, all those things right there at the front. Quick items that might be impulse buys. So we know that the location of the product might control whether or not they like it. So we're going to circle C. This is not a good design. And ultimately, C sounds worse than E. Whether or not I choose a month's time doesn't really, the amount of time I choose doesn't sound like it's going to matter. Thanks for joining us.